You are welcome to today's lesson. So we continue with stoichiometry and more concepts. We have laid the foundation with lessons 1, 2, and now we continue going into details with lesson 3, and we are looking at the limiting reagents. Alright, so to begin with, what is a limiting reagent? So by definition, we are saying a limiting reagent is a reactant that is in short supply by the mole ratio, and hence it finishes before the other reactants are completely reacted. For example, when you are cooking nshima, so we are taking a scenario of a typical Zambian child. We love nshima. So when you are cooking nshima, you understand that you need some meal, you need water, and you need a pot. So any of these three things that are mentioned can determine how much nshima you're going to prepare. For example, you can have a very big pot, a lot of water, but if you have little meal, then the one which is going to determine how much nshima you're going to prepare is meal. Therefore, meal becomes your limiting reactant. That's what this definition is saying. Maybe I add on to this example. You can also have a lot of meal, a lot of water, but a small pot. So as long as you have a small pot there, meaning you cannot cook a big shima, so your small pot becomes a limiting reactant. Okay, and so on and so forth. I hope you are getting the idea. So that's why they are saying the reactant that is in short supply by mole ratio. So the one which finishes faster than the other is the one that is a limiting reactant. So the reason why it finishes faster than the other is because it is less than the other. Okay. Alright, just to add more flesh, we are saying a limiting reactant is always smaller or in less quantity compared to the other reactant. Alright, so a limiting reactant is found by dividing the number of moles of each reactant by its stoichiometrical coefficient in a balanced chemical equation. So we're gonna understand that one just in a little while. Okay, so now we are saying the ratio that is smaller is that of a limiting reactant. So a limiting reactant has less number of moles compared to the other reactant. Now please take note of this foundation that we are laying before we can dive into the calculations. So a limiting reactant determines the extent to which the chemical reaction can proceed and the amount of product that will be formed. Once the limiting reagent is finished, then the reaction stops. So like I was saying, once you are cooking nshima and you have less meal, a big pot, and a lot of water, so once meal finishes, you can no longer cook nshima, meaning you will no longer have nshima, but you're only going to have porridge of some sort. So that is what we are trying to say here. So the one that determines how much product is formed is actually the limiting reactant. That is what you're trying to say in this explanation here. Alright, so for this reason, it is important to identify the limiting reagent before calculating the theoretical yield. So later on in our pursuit of more concepts, we are going to encounter something called theoretical yield, meaning how much product is expected to be produced from a certain reaction. So now, to know this one, you need to understand the concept of what is limiting reactants, because the limiting reactant is the one that is going to determine how much product is going to be produced. Alright, so now, in as much as we are saying the limiting reactant, there is an opposite of a limiting reactant, and the opposite of a limiting reactant is the one that we call an excess reagent. So there is a reagent that is in excess. So an excess reagent is a reactant that remains unreacted at the end of the reaction. Now, you have two reactions. You have water, you have meal. So as long as you are adding that meal to the water, there is some sort of reaction that is taking place, and the water is slowly changing into some solid stuff. But as long as the meal finishes, then the reaction stops. It will stop at the extent where it has reached. It will no longer keep on being solid, hard and hard. Alright, let's see now what we are supposed to do in here. Because in the exam or anywhere else in chemistry, we are required to determine the limiting reagents through calculations. So how we achieve this is by simply writing a balanced chemical equation. So you know balancing by now. Then the next step that you're going to take is you're going to express the reactants in terms of their mole ratios. Remember, when we are dealing with calculations from equation, which was the mole to mole reactions, we showed you how to write, how to express a chemical reaction in terms of what? Mole ratio. So that knowledge is going to be very cardinal as we begin this. Alright, let's look at an example here, how we can handle this knowledge that we have just been taught. Alright, so we are saying 19.5 grams of zinc and 9.4 grams of sulfur were heated together. I hope people have got calculators and periodic tables nearby. You need those to understand this. Okay, so which of the two is the limiting reactants? Now, we are just talking about the reactants. So our major goal is just the reactants, which happens to be these species that are on the left side here. So the limiting reactor, so one of these, either zinc or sulfur, can be the limiting, but we can never guess. We have to do something to the equation. Alright, now, before we can dive into what we are supposed to do, let's just read through the questions, then we'll answer them on the next board. So, B says, how many moles of zinc remain unreacted? How many grams of zinc remain unreacted? Okay, so how many moles of zinc, then how many grams? Here they are asking for the moles, here they are asking for the grams. Then now here we are calculating the mass of what? Zinc sulfide that is formed. Alright, first things first, when we go to the solutions, we have to make sure that we balance the chemical equation. Now, roughly, before I start solving these questions, remember, if we had a reaction like A reacting with what? B, so we have A, which is reacting with B, and then this one is producing two products called C and D. So by now, we expect that people have got an idea on how to do the equation. So now, this is just an equation which is not balanced. Remember, balancing, we do it by adding some numbers in front here, the coefficients in front of the reacting species and the products as well. So here, let's say we are balancing this one by writing A, then here we also balance by putting a certain number called B, then here we also balance it with C, then here we can balance it with D. Now remember, because we are dealing with limiting reactants, our interest is just this part. So we are just going to express this part in terms of its mole ratios. So we are going to say number of moles of A, so number of moles of A over the number that is in front here, which is A, is equal to number of moles of B, so this is number of moles of B over B. So this is what is called expressing in terms of mole ratios. Now, please remember, expressing in terms of mole ratios can only be done after the equation has been balanced. Then that's when you can do your what? Your calculations. Alright, we proceed. So we go, now we do the solutions here. So A, let's see if we can solve A, question A. So everything is based on the reaction. We are saying this is zinc, which is reacting with sulfur, and this one was producing actually what is called zinc sulfide. So we can balance our equation here. We have one zinc there, we have one zinc, we have one sulfur, we have one sulfur. So this equation is self-balanced, which means there are invisible ones in front of these species that are in the equation. Alright, so now if we are to check here, we can express this one in terms of mole ratios. So we are saying number of moles of zinc, so number of moles of zinc over 1 is equal to number of moles of sulfur over 1. Alright, now remember from the lesson 1, we said number of moles is given by the formula mass over molar mass. So number of moles is given by the formula mass over molar mass. Now remember, from the equation here, we've been given zinc. Okay, we've been given zinc. So this zinc here, the zinc actually here has got, so using your periodic table, okay, we can use our periodic tables just to confirm. You can check the details from the periodic table. So let me check my periodic table. I hope you have your own periodic table also, because without the periodic table, then we are going to have problems. Alright, so here they've given us, when you're dealing with zinc, they've given us the mass, which is 19.5 grams. So that is the mass. So substituting into here, if you're finding for zinc here, this one is going to be, they are saying they've given us 19.5 grams. Alright, so this one here is equals to 19.5 grams. Okay, so that is 19.5 grams over, on the periodic table, when you check the molar mass, you find that it is 65 grams per mole. So this is 65 grams per mole. You can simply punch on the calculator. That is why we said you need a calculator. So you can punch on the calculator there, and let me punch so that you can also follow through as we are punching. Make sure you have your own calculator. So we are saying 19.5 grams divided by 65 grams, and this one is giving us 0.3. So this gram and that gram goes, so we'll remain with 0.3 moles. So we have found the number of moles, 0.3 moles. We do the same also for sulfur. So the number of moles of sulfur is equals to, using the same formula, mass over molar mass. Then from the equation here, they've told us the mass of sulfur was 19.4 grams. So we continue. This one we are just substituting by putting 9.4 grams. Okay, so that is our 9.4 grams divided by sulfur has got 32 on the periodic table. So that is 32 grams per mole. Okay, 32 grams per mole. So punching that one on the calculator, okay, you can punch, make sure you are following through. So that is 9.4 divided by 32, and this one is giving us a value of 0.29375. So we can round it off to 2 decimal places, so that the answer just becomes 0.29 moles. So 0.29 what? Moles. Alright, now having done that, we are going to substitute into the equation. Remember, the equation we are saying number of moles of zinc over 1 should be the same as number of moles of sulfur over 1. Now, if we substitute, we are going to have 0.3 divided by 1, which is equal to 0.29 divided by 1. So you find that this one will not be true, because we are going to have 0.3, okay, 0.3, and on the other side, so for zinc here, we are going to have the number of moles to be 0.3, and then for sulfur, so the number of moles of sulfur, the number of moles of zinc is 0.3, the number of moles of sulfur will simply be 0.29. So now remember, we are determining the limiting reactant, and from the definition, we learned that the limiting reactant is the one that gives you a less number of moles when you express in terms of mole ratio. So after expressing in terms of mole ratios, that's when you can determine which one is smaller. So because here we are dividing by 1, it remains 0.3. Also here by 1, it remains 0.29. So since sulfur here, okay, so we are saying since the number of moles of sulfur are less than the number of moles of what? Zinc. Therefore, the limiting reactant here, so the limiting, you write the full word, the limiting reactant here will simply be what? Sulfur. And that is how you determine. Alright, you can pause, play the video, and see if it is making sense for you. It should make sense actually. Okay, B. How many moles of zinc remained unreacted? So now, guess what? The idea here is very simple. These, they should be in equal amounts. So if you have 2 grams, meaning here we need 2 grams. So if they are each the same, then the reaction is going to be the same. So because here we had 0.3 moles and here we had 0.29. So the moment these moles here, because 0.3 is big, so the moment the moles of zinc reached 0.29, it means the reaction stopped. So the excess moles remained. So we are just going to subtract this and that. So to find the excess moles, or the moles that remained unreacted, so excess moles are the moles that remained unreacted, or that remains unreacted. So to find that one, you just have to subtract. So excess, so moles in excess, So you can just say number of moles in excess here. Write the full words, please. Number of moles in excess. This one you're just going to say it's 0.3 moles. Okay, so 0.3 moles minus 0.29 moles. So this is 0.29 what? Moles. Then this one here, it will give us 0.001 moles. So these are the moles in excess. Alright. Then here we go to C. They are saying how many grams of zinc. So here they are emphasizing how many moles of zinc element remained unreacted. So we go to see how many moles of zinc remained unreacted. Now we know that number of moles is equals to mass over molar mass. So mass over molar mass. So if we are making this one, so since we are finding mass, we need to make M the subject of the formula. So we are going to say mass is simply equal to number of moles multiplied by what? Molar mass. Okay, so substituting into this one, we are going to have number of moles. Now we are talking about the ones that remained unreacted. Okay, the mass that remained unreacted. So we are going to use the excess moles here. Okay, so this one will be 0.01 moles. So 0.01 moles multiplied by zinc is actually 65 grams per mole. So 65 grams per what? Per mole. So that the mole and the mole can cancel, and the answer we are going to have is 0.65 grams. So you can easily punch that one on your calculator, and this is the answer that you're going to find. Okay. Question D, calculate the mass of zinc sulfide formed. Now remember, like I was saying, here you can use this information to find this one, or you can use this information to find this one. But how do you decide? So this is very simple. In order for you to know how much mass is produced, you first of all need to know the limiting reactant. So since we found that sulfur was the limiting reactant, so what we are going to do is we are going to say the number of moles of sulfur over 1 is equals to the number of moles of what? Zinc sulfide over 1. So we have chosen sulfur because it is the limiting. So in order for you to know how much mass is produced, it all depends on the limiting reactant. So that's why we are using the what? The limiting what? Reactant. So number of moles of this one should be equal to number of moles of that one. So number of moles of sulfur, we know that it was 0.29 over 1 is equal to the number of moles of zinc sulfide here, also over 1. So we can cross multiply, and this one will give us number of moles of zinc sulfide will be given as, because this is just 1 times that one, which doesn't change anything. So the reacting mole ratio is 1 to 1. Therefore, this is what you're going to have. So the number of moles of that one will be 0.29 moles. Alright, so we have found that one, but they want the mass. So now to find the mass, the same procedure that we used, number of moles is equals to mass over molar mass. So that is mass over molar mass. You can make M the subject of the formula, cross multiply. So we're going to have mass being equal to the number of moles multiplied by what? Molar mass. Now remember, here we are determining for zinc sulfide. So to find the molar mass for zinc sulfide, remember, you just need to write zinc sulfide like that. Then you do, remember what we did at first. So this is 1 multiplied by the mass number of sulfur, which is 32. Okay, then you also need zinc 1 times 65. So these the answers. This one will be 32. Okay, and this one also will be 65. So we can add that one, 2 plus 5, that is 7. Then this is the 9. So the answer is 97 grams per watt per mole. So this is what you're going to have. So we go back, we multiply here. This one will be 0.29 moles. Okay, 0.29 moles multiplied by 97. So this is 97 grams per what? Per mole. So this is what we're going to have. The mole and the mole will go. So we can quickly punch on our calculator. We punch, that is 0.29 multiplied by 97. So multiplied by 97, and this one is giving us 28. 28. So 0.29 multiplied by, so this is 28.13. Okay, so 28.13 grams. So this is the mass that it is giving us. So please follow the procedure. Example 2 reads, how many grams of hydrogen chloride would be produced from 0.49 grams of hydrogen and 50 grams of chlorine? Alright, so the first thing is to write the balanced chemical equation. So here we know that the hydrogen is the one that is reacting with chlorine to produce hydrogen chloride. So we are going to write, this is hydrogen. Remember, hydrogen is diatomic. So this is hydrogen gas. You put your state symbols, which are not necessary as of now, but remember, chemistry always needs a balanced chemical equation and state symbols. So you also react it with what? With chlorine, which is also diatomic. Every time you're writing in an equation, make sure you write it as a diatomic. So this one will give us hydrogen chloride. By now, you know how to come up with the formulas, and this one is aqueous. Alright, so having written this one, then you are going to check. You have 2 hydrogens, 1 hydrogen. 2 hydrogens on the left side, then one chlorine there. So 2 chlorine, 1 chlorine. So we can balance by putting coefficients in front of the reactant species. So when you put 2 here, then everything will become what? Balanced. Alright, now the question here is saying, how many grams of hydrogen chloride would be produced from 0.4? So now you are looking for the amount of the product. Now remember, the amount of the product is determined by the limiting reagent. So the first thing that we have to do first is to determine the limiting reagent. And to determine the limiting reagent, you are going to express the reactants as in terms of mole ratios. So number of moles of hydrogen there divided by 1, because there's a 1 in front, is equals to the number of moles of chlorine there. So chlorine Cl2 divided by 1. Now we know that for sure number of moles is given by the formula mass over molar mass. Okay, so mass over molar mass. So meaning number of moles of H2 here, of H2 will be equal to, according to the question, it's 0.49 grams, that is the mass. So we're going to write 0.49, so that is 0.49 grams divided by the molar mass. Because it's H2, it is going to be 2, so we divide by 2. We know that on the periodic table it is 1, but 1 times 2 of these, it gives us 2. So the answer here, we simply punch on the calculator. So that is 0.49 divided by 2. Okay, and this one is giving me 0.245. So this one is 0.245 moles. So that is the answer, 0.245 what? Moles. Then you also calculate for number of moles of Cl2, which will be equal to, we know it's mass over molar mass. So the mass being given in the question here is 50 grams, which is this one here, 50 grams divided by, so that is 50 grams divided by chlorine, it's 35. On the periodic table when you check, it's 35.5, multiplying by 2 because it's Cl2, it is going to be 71. So this is 71 grams per mole. So 71 grams per mole. Punch that on the calculator. Let's see what we get. So that is 50 divided by 71, and this one is giving us about 0.7. So we have 0.7 moles. So this is what we have. Now comparing the two, we have 0.245 moles and 0.7 moles. So the limiting reagent is the one which has got less. Now that less is when you divide. So number of moles of hydrogen, this one will be over 1, which should be equal to number of moles of chlorine here, which is 0.7 over 1 as well. So 0.7 over 1. Let me just write this one properly. So over 1. So you discover that the number of moles of hydrogen here, so number of moles of hydrogen is less than the number of moles of chlorine by mole ratio. Therefore, our limiting here is what? Is hydrogen. So the limiting is hydrogen, meaning to determine the amount of product formed here, we are simply going to say number of moles of hydrogen here, number of moles of hydrogen over 1 is equal to the number of moles of HCl. Okay, so HCl over 2. So we can cross multiply this one here. Now number of moles of hydrogen we know from here is 0.245. So this one will be 0.245 over 1 is equal to number of moles of HCl. So this is number of moles of HCl over 2. So we cross multiply this one. We are going to find number of moles of HCl here. Number of moles of HCl is equal to 0.245 times 2. This one will give us 0.49. So the answer is 0.49 moles. So we have determined the moles of HCl. So now the only way we can know the mass is first by determining the number of moles. So that's why we started by first using the mole to mole calculation. We found the number of moles of this one. Now we can use the formula. Number of moles is equal to HCl. Number of moles is equals to mass over molar mass. Then over 1, this one, we make M the subject to the formula. This one will be M is equals to number of moles times what? Times the molar mass. Alright, so the mass of HCl here will be equal to its number of moles is 0.49, then times the molar mass here, we know it's C. The molar mass for HCl is actually this one is 35.5 plus 1, which is 36.5. So this one will be 36.5. So we can punch on the calculator and see what we're going to come up with. So that is 36.5 multiplied by 0.49. This one is giving us 17.88. So which is just the same as 17.9. So this is 17.9 grams, and that is how you determine the mass. So remember, this example was just meant to emphasize that what determines the amount of product formed is the limiting reagent. So they asked us to determine the amount of product formed here, but for us to do that, we were first supposed to identify the limiting reactant. Then that's when we can calculate. Alright, example number 3. This one reads, how many moles of iron trioxide can be obtained by reacting 16.8 grams of iron with 10 grams of steam? So also here we need to write the balanced chemical reaction. So how many moles of iron trioxide can be obtained by reacting 16.8 grams of iron and steam? So here they are saying iron. So iron is Fe, reacting with steam. Steam is just water, which is H2O. So this is H2O. Now this one has to be in gaseous state. Then iron, we know that it's a solid. So state symbol here is solid. Then this one here, it has to produce what? Iron trioxide. That's what they've told us. So this is Fe3, then O4. So Fe3, then O4, then plus. Now we know from the simple rule that whenever a metal reacts with water, there should be a hydroxide and hydrogen gas. But in this instance, we've been told that it is only the iron trioxide that was produced. So we have to work with what we have to see what exactly was being produced. So, but one thing for sure, the point I'm trying to make is hydrogen is what is produced. So this is the hydrogen gas that is produced. So whenever there is a metal and water reacting somewhere, hydrogen gas is always what evolved. So we can balance the equation here. We have one ion, we have 3 ion here. So we have 1 ion and we have what 3 ion. So we can balance it up, because the best thing to do, since we have 3, we can just add a 3 here so that we have a 3. Then we have 4 oxygen, so meaning here automatically we are going to add a 4. And then this one gives us 4 times 2, that is 8. So since we have 8 hydrogen here, it also means that we can add a 4 so that we have 8 what hydrogen, and that is our balanced chemical what equation. Alright, so we have balanced our sorry, let me just confirm. So we have 4 hydrogen. Okay, 4. Okay, everything is balanced here. So this is the balanced chemical equation. Now they are saying how many moles of iron can be obtained by reacting 16.8 grams of iron, 16.8 with 10 grams of steam. So how many moles of what? How many moles of iron? This one here, this is the one they want. And then here they've given us 30. So the first thing, we are looking at these two guys that have been given, because they've said 16.8 grams of what? Iron. So this is the one that is here. So here we are just going to say number of moles of iron. So we express in terms of mole ratio of iron divided by, in front we have a 3. This one should be equal to the number of moles of steam, which is this one here. So number of moles of steam, which is H2O. So steam is simply hot water, divided by the 4 which is in front here. Okay, now remember, number of moles we have been seeing in here, it is given by the formula mass over molar mass. So mass over molar mass. So here we just substitute. If we are finding for iron, we are just going to say, since they've given us that it's 16.8 grams, so for iron we know it's 16.8 grams divided by, so we can check our periodic table. So I have a soft copy periodic table with me here. So let me just check. Iron actually has 56 grams per mole. So this is 56 grams per mole. So that is 56 grams per watt per mole. So we work that one out. We're going to find, you can use a calculator. So that one will be 16.8 divided by 56, and our answer is 0.3. So the number of moles there is 0.3. So 0.3 moles of what? Iron, which is Fe. So we can also determine now for what? Number of moles of water, which is steam. Okay, so steam here will simply be the mass. They've told us 10 grams. So 10 grams, right? The 10 grams over. By now you know how to find the molar mass, because molar mass of water here, we know water is H2O. So we're going to have 16 plus 2, which is 18. So this one will be 18 grams per watt per mole. So we do that, then this one is going to be, so 10 divided by 18. So 10 divided by 18, and this one is nearly 0.5. It's a recurring decimal. Okay, so that one is going to be a recurring decimal, which we can just round off to 0.56 moles. Okay, so now that we have this one, substituting into this equation which says number of moles of iron over 3, so the number of moles is 0.3. So we're going to have 0.3 over 3 is equal to number of moles of steam here, which is 0.56. So 0.56, and this one will be over 4. So having divided, let's see what we're going to come up with. So after we divide, what are we going to come up with? So we divide 0.3 divided by 3. Obviously that one will be 0.1, which should be the same as we divide. So just 0.3, you can even use a calculator, which is 0.1. Then you can also divide 0.56. So 0.56 divided by 4, and this one is giving us 0.14. So 0.14. So this one is 0.14. 0.14. Now, this number is automatically bigger than this one. So we are going to say, since number of moles of iron here, number of moles of iron is less than number of moles of steel. Okay, number of moles of steel. It simply means that iron here, Fe, is the limiting. Is the what? The limiting. Okay, so this is the limiting that we have. So iron is our limiting. So if iron is our limiting, then we know that we can create a relationship between iron and the product, which will be like number of moles of iron, which is Fe divided by 3, which should be equal to number of moles of Fe, the product, which is Fe, then 3 or 4 like that, divided by here, since there is nothing in front, this one will just be divided by 1. So number of moles of Fe, we know it's what? 0.3 as we have found. So 0.3 divided by 3, this one gives us 0.1, which is equal to number of moles of Fe, or 4 there, over 1. So even if we cross multiply here, okay, so even if we cross multiply, we're still going to have number of moles of Fe is equal to 0.1. And we have determined, because the question says how many moles of iron trioxide can be obtained by reacting what is 16.8 grams. So we have done exactly what they wanted us to do. Alright, having listened to these examples, let's see if you can practice. This is what you can practice. These are the questions. Pause, read through the screen, and answer these questions, then get back to me and see how we can progress from here. So these are the questions. So question 2, that is what you're finding, and that marks the end of limiting reactants. And stay tuned for lesson number 4 rather, and see what next we are going to learn.